Bum 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 bum.
Tomatoes?
Hello, welcome to the video for what is World Transform. Let's go ahead and run through this example. We're not actually going to play it until we get things set up, so let's see how this stuff works. We have a setter and a getter for World Transform. If we type in World Transform and spell it correctly, it's not going to show up. If you uncheck context sensitivity, it will show up. And it's going to basically only show up in here because we've told it, hey, we don't care what it is. Let's pull up the setter for the World Transform. You're going to get what I have here. And it needs a scene component. The scene component is part of a blueprint, and it's basically going to be something that has a transform. Some components have transforms, like my cube, sphere, and cylinder here. Some items don't, like this pawn sensor. So this pawn sensor will not show up as a valid target for anything that needs a scene component. Yeah, I can actually show you that here. Let me save this. Let me go to my created box, and we will get. And we're going to look and see what we can get. Oops, context sensitive. And we will see what we can get out of my created box. And right here. And you can see we have a cube, a cylinder, pawn sensing, scene, and sphere. Now if we were to pull out the pawn sensing, like this, and plug it in, it's going to fail. Pawn sensings do not have a scene component anywhere in their parent-child relationship chain, so it's not going to work. For example, we're going to pull out the cube. Get our cube, and plug it in, and there we go. We're going to go ahead and hit compile, and we're going to fail. We need a transform. Transforms are, let me unplug these and recombine. They are locations, rotations, and scales. A vector, a rotator, and a vector. And that's what makes up a transform. This transform here is completely empty right now. Nothing's plugged in, and it has no values, so it's going to fail. That's the error. We can split it and compile, and now it's going to work because we have a 0 for the location, 0 for the rotation, and a 1 for the scale. For my example, I'm going to recombine and plug this in, just because I like seeing this node here. You don't have to use it, you can use it either way. So we need a location, rotation, and scale for our cube to now take. What I'm going to do is split my scale, because it's a struct, and plug in my x, y, and z. We'll go ahead and we'll hit play. Now if I adjust my scale, we're going to see two things happen. We're going to see the scale of my box go up and down, or left and right, or I guess in and out. One was in and out, one was left and right. But it's going to scale appropriately. But you also notice it's no longer where it was at originally. It's at a different spot. That's correct. When I told it to make a new transform here, and I told it to set it as the new transform, I am actually telling it, even though nothing's plugged in here to location or rotation, I did mention it's a valid value. I'm telling it now to change its location to 0, 0, 0, and its rotation to zeros across the board. When I spawned this box originally, I'm actually telling it to spawn at 150 on the Z. So when this item is changed, oops, let's open up in here, go over here, look at our transform boxes, look at our cube. This is where it spawns at if we go to our world version. World, world, and world. Its location is 0, 0, 150, rotation is 0 across, and scale is 1 across. When I adjust the scale, you're going to see the location change appropriately. And you'll see the scale change appropriately. So now we have a scale of 2 and a location of 0 all the way across with a rotation of 0 all the way across, which is exactly what I told it to do here. So that's how we would set the transform. Keep in mind it is on the individual scene component. So it's the individual item inside of here. If I wanted to, I could target the cylinder or the sphere and it would change just that. The getter is going to run the same way. Let's recombine this. You're going to need a scene component. In this case, well, why not? Let's go with the sphere because why not? We're going to talk to the created box, get the sphere, and it's going to give you back a transform. You can split the transform into the values and then split those values again into individual floats. So we're good to go there. Now, a couple things to note. we have two more values. We have the sweep option and we have the teleport option. And we'll cover those now. Let's cover the teleport first. It's easiest. Teleport basically is if you're using physics and you want physics to continue after this set here, after the set. Physics will attempt to simulate the physics after the move. For example, if I was to move this item 1,000 on the Z, straight up in the air, and physics was enabled, it's going to, after that movement, one frame, it's going to move 1,000 units. And right after that movement, it's going to instantly freak out because it's got a lot of physics to simulate for that big of a distance over that short of a time. So if you're teleporting something, and I'm using quotations here, as in you're going to move the location, rotation, or scale a large amount over one amount of time, and you're using physics, and you want the physics basically to pause, then you're going to want to go ahead and check teleport, and that's going to pause the physics when the action occurs. So it'll basically pause, do your setter, and then unpause is how teleporting will work. Sweeping, let's go ahead and adjust this. Let's change this to here. Whoops. Let's actually split my location. Set this up like this. Let's go back into here. On my Y, I'm going to change my maximum Y to something like 1,000. And I'm going to show you this example here. So, whoops, here, and play. If we were to adjust the Y on here, you'll notice my box, what did I change? Oh, okay, so this is one, this is one of those instances where when you're using transform, pay attention. If you notice what I did here, I am making the scale 0 for the item, and it kind of messed it up. Let's try this again, shall we? Now when I move it on the Y, there we go, you should see it moving. And let's actually make we don't need to worry about the Z. We'll do 150. And we'll go ahead and play. And let's try that again. And there we go. You'll notice the cube goes through my wall. My wall is set to blocking. It should be blocking the cube. However, it's not because it's not carrying. If we turn on sweep, and then we go ahead and play, and we'll see what happens. You'll see, well, I can now move it past in terms of the numbers, but it's blocking it physically. When you have sweep enabled, basically from the starting point to the ending point of the sweep, so basically wherever you're telling it is currently to where it's going to check. It's going to see if anything should be triggered, anything should be blocking it based on collisions, and it's going to go from there. If it is, it's going to give you back a sweep hit result. And this is just a normal hit result, which gives you back things such as, was it blocking, was it overlapping, where did it hit, and things like that. So that's something to keep in mind. If you're going to want to make sure your bullet or your item or your character is physically interacting in the world, normally you'll probably want sweep on to make sure it prevents it from moving through things or it triggers a trigger. That is going to wrap up our set world and get world transform nodes. They are used for setting and getting the world transform of an item. They need a scene component for the input. So that's pretty much going to be any blueprint component attached to your blueprint that has a transform. And it's only going to move that individual item. And it's going to move it in the world. It's not relative. For example, if I said set world location 00200, it's not going to move it 200 away from the root of my actor. It's going to move it to that location in the world no matter where it is.